and welcome back to our Jumpstart, virtualizing your data center with Hyper-V and System Center. I'm Simon Perryman, joined again by Matt McSpirit, and in this module we're going to be focusing on two kind of key elements, high availability and clustering, as well as actually deploying and configuring virtual machines. But before we really dive into that, I'm going to turn it back over to Matt, and we're going to just do a few final steps wrapping up our virtual network deployment.
Correct, yes. So there's a few little bits that I want to go through just to build that logical switch that we alluded to, because the first time you start to learn about a logical switch, it takes a little while to sink in, and I think having it visually demonstrated on how the kind of process we go through and what that looks like will help you. So firstly, I'm back in VMM. I'm over in my Fabric view again, and I'm looking at my logical networks, and I'm going to create a logical network. And remember, we said logical networks are a way for us to abstract and define the different networks within our environment. It may be that you start with just matching the physical networks you have in your environment. As you can see, mine, Heartbeat, Live Migration, Storage 1, Storage 2, and I'm going to create one that is going to be called Contoso LAN. It's effectively going to be used for management. But I'm also going to tick a few boxes here to allow not only VMs created on the top of this, I'm going to be able to use network virtualization to isolate them, but I'm also, and we'll look at that a bit later on, but I'm also going to create a VM network so that some VMs that operate on this same management network as the hosts is also going to work as well. I could use VLANs or PVLANs if I want to. Here's this sites that I talked about before. I'm just going to create a new site. Remember, your logical network could span sites, could span buildings, however you want to define it. And I'm going to use any host that appears in my all host group. In this case, I've just got the one folder or host group that's containing all of my hosts. But if I split my host groups up into buildings, I could apply different logical networks and sites to different buildings. So I'm going to give this a particular subnet. The VLAN is going to be 0, and this is going to be 192.168.1.0/24. So this is essentially saying that this particular site, of which I can add multiple within the same logical network, is going to apply to these hosts, and the VLANs and subnets that we're going to apply to this particular site are here as well. So we'll go next and finish. And that's effectively created a logical network. So that's all good there. So now that we've got our logical network, I can create an associated IP pool. So I've got Contoso LAN. I'm going to right-click, create an IP pool, and I'm going to call this, remember this was what we were talking about before with VMM managing the IP address assignment of a particular set of IP addresses within a particular logical network. So I'll go next. The site it's going to use is going to be the one we just defined. So any hosts that are going to be sitting in this particular network site, VMM can IP address them, certainly at deployment time when it's deploying new hosts. Any host groups we've seen, that's already grayed out because it's defined by the network site itself. The IP address range, I'm going to shrink this a little bit to 10 and 100, which means VMM is going to actually deploy only IP addresses within that range to hosts that match that, or VMs if that's appropriate. I can reserve some IP addresses for load balancers, or for maybe some machines have already been deployed that have got an IP address within there that I want to reserve. That's fine, I can define those as well. The gateway, I'm going to define as 192.168.1.254, and the DNS server is 192.168.1.1. Don't need the rest of the text on there. There we go. And I'm going to enter a new suffix of contoso.com. I'm not using wins, so that's fine. Next, finish. So that's now VMM is going to manage not only the logical network itself and when machines fit into that logical network or when we deploy new hosts and attach them to that logical network, but it's also going to handle the IP address assigning, of which there are 91 addresses that it can choose from for that particular purpose. Now we want to make sure that our hosts that have already been deployed, that are now in our all host view, we want to make sure that they are on the right logical networks. So I'm going to go into this particular properties view of Hyper-V 01, into hardware, and make sure that the NICs in this environment, so I'll NIC 1, I'll put it on the right logical networks. You'll notice I've done some of them already. Management as well, I'll do that one. On Contoso LAN, yeah, that's okay. You'll see some of them here. So I've got a live migration network. I've put that on the live migration logical network. So it just helps me to classify and organize my particular configuration within my environment, my network settings. And these are the physical hardware-based NICs. This isn't any vNIC-specific stuff here. This isn't virtual machine-specific. This is to the host level. So it's helping me to organize and manage that from that process. So I'll go OK. And while it's doing that, I'll do the same for Hyper-V 02. So again, all I'm doing here is just assigning logical networks. It's not going to change the IP address or do anything magical from that perspective. It's just going to make sure that VMM is aware that that particular network adapter of that particular host is on within that network, which is handy from a management perspective. So it starts to build a more deep understanding of just what's going on in your environment. If VMM has deployed this host from bare metal, it will already have done all this for you, but because we're inheriting these Hyper-V machines, there's a little bit of extra kind of applying VMM's knowledge and control into that environment. But once you've done that, you're pretty much good to go. So now that we've got our logical network, if we go back into our environment, I've applied my logical network, so now I can create a port profile and classification. And if I look at my port profiles down in the network view, and I right-click and say Create Hyper-V Port Profile, there are two types. Remember we talked about them before? There's one type of port profile, like a port template, that applies to physical NICs, and there's another kind of port template that applies to virtual NICs. We're going to do the physical NIC one first, and I'm going to call this one Contoso Uplink. And this is going to be the standard profile template, if you will, that's going to apply to physical network adapters that are going to be transformed into vSwitches in my environment. And it's saying, okay, you've chosen uplink port profile, so choose your load balancing algorithm. I'm just going to leave this as address hash in my environment. That's the most relevant. And you may have teaming. You may have to choose a specific teaming mode that reflects your hosts and your physical switches that are beyond your hosts. So it may be that your teaming mode needs to differ based on that. Whichever one, I'm just going to leave it as switch independent. But what this means is whenever I apply this port profile to some physical adapters, A, it's going to team them together, and B, it's going to team them with that load balancing algorithm and that teaming mode. So if I wanted that to be consistent across all of my organization, I would just need the one uplink port profile. But if I've got specific requirements across different buildings, for instance, that may be using different switch infrastructure, I may need to create multiple uplink port profiles and apply them to the respective hosts in those buildings. But that's a good way to think about it. So I'm going to go next. Which sites are going to be supported by this uplink port profile? So in our simple infrastructure, our Contoso LAN, our network site, is going to cover all of our hosts, which means I'm just going to tick that box. However, if you had an environment where you had lots of different sites, it may be that you tick lots of boxes where this generic uplink profile we've just created is applicable. On the other hand, it may be that this profile, this port profile, only maps to one network site, and you may need to maintain multiple of each. But that's up to you. I'm going to go next and finish. So that's all I needed to do from a uplink port profile. So that means that now when I apply a logical switch, it's going to convert it into a vSwitch and apply that particular uplink port profile that we've defined. Now on the back of that, I need to also create and configure a new host VNIC, or a new virtual network port profile. So we saw the other option there. So I'm going to create Hyper-V port profile again. Virtual network adapter port profile. I'm going to call this one Contoso VNIC. And what you'll find is this particular VNIC, I'm ticking this top radio button here, go next. Notice the number of options I have is very different because this is specific settings associated with a virtual network adapter. So it may be that you want to turn on certain settings consistently across all of your VMs. Well, in which case you tick the boxes, you go next, you tick the relevant security settings in this case that you want to make part of your VNIC template, and you click next. Any bandwidth setting, remember we talked about quality of service before. I'm going to set a maximum bandwidth setting here of 100 megabits per second, which means if any virtual machine gets this VNIC port profile attached to it, its traffic is going to be limited to 100 meg. Okay, so if I want to consistently roll that out across the board, having this as a virtual adapter port profile is very useful because it saves me setting this setting on every single VNIC across all the VMs. I can just do it in one place and assign that virtual NIC port profile to that particular VM. So finish. So we've created the two different types of port profiles there, the uplink for physical adapters, the VNIC port profile for the virtual network adapters. So we're good to go there. But as I said before, we might want to mask some of the detail of this particular virtual profile we just created. We want to mask that behind something like a classification. And to do that, I'm going to go to my port classifications. You'll see I've created one in advance. It's the only one without a description. Contoso standard port. This may be high bandwidth port. It may be medium bandwidth. It may be certain security port. Whatever you define the name, give it a description. And what that means is when we deploy the logical switch, we're actually assigning and attaching all of these components together so it makes a little bit more sense. So we can now create our logical switch. We've got all of the building blocks. So I'll click Create Logical Switch. You'll see it's the longest description of Getting Started Wizard you'll probably find in VMM, but basically it's saying, have you got logical networks? Yes. Have you got the switch extensions enabled and installed in VMM for management? No, we haven't because we're not using any, but that's fine. If you're not using any, have you got your port profiles for the physical NICs? Yes. Have you got port profiles for your virtual NICs, for your VMs that will attach to this physical set of NICs? Yes. We're good to go then. So let's call this one, we're going to call it Contoso LS. This is the only time I can enable SRIOV, but I'm not going to do that here. I'm going to go next. There's any switch extensions, but we'll accept the default. But if we add the Cisco or 5.9 solutions, we could tick those boxes if they were installed and configured. Now, uplink. This is basically saying, okay, when we deploy this logical switch onto a host, you're going to select a couple of network adapters. What uplink profile, what uplink template do you want to use with this configuration? I'm going to choose add. We've only got the one. It's the one we just created. Remember, it's got a certain teaming configuration. It's got a certain load balancing configuration. That's what we're going to use. But I have this option to say, okay, is this uplink profile going to be applied typically to a single network adapter, or is it going to be applied to a team? 9 times out of 10, when you're deploying a vSwitch, you're going to be binding it to multiple NICs, physical NICs in the underlying system for resilience. So mostly you're probably going to click team. Because of our nested environment and some of the quirks that we encounter, I'm going to do no uplink team. But for the purpose of your production environments, for the most part, you're most likely to select team. And what that means is when you go through the wizard of deploying the logical switch, because remember at this stage we're only just creating it, when you go through the wizard of deploying, it will ask you for more than one physical adapter to bind to. Okay, so that's important. I'm going to leave this as no uplink team. And then finally, specify the port classifications for virtual ports, part of this logical switch. What this means is any VMs that are going to use this logical switch to get out to the network, to communicate out into the rest of the network, you're going to say which virtual ports can I use with this logical switch. So any VM that you want to attach to this logical switch, it's going to have to be using one of these classifications. So I'll go add port classification. I'll choose our standard port. Now notice as part of this wizard, I can also include a VNIC adapter port profile as part of this. So we'll choose our Contoso VNIC. So what this would mean, if I left this as standard and click next and finish, anytime I created a VM, if I wanted it to attach to this logical switch, this Hyper-V logical switch, it would need to have this Contoso standard port classification as the VM settings, in the VM NIC settings. That's the only way it would work. Okay. Alternatively, I can add a couple of others, like for instance, high bandwidth, and include a particular NIC profile with that. So at least we've got a few choices we can provide to users who are creating VMs. Medium bandwidth. Now you could associate these classifications with any of the actual network adapter port profile. Remember, the classification is just a name. The port profile actually contains some meaningful settings and policy, as we saw before when we created the standard port. I'm going to create the final one as low. I think that's about it. I don't think there's any more that we need to create. No, that's good to go. And our default is going to be the standard port. So next, and finish. And quick as that, we've now created a new Hyper-V logical switch. So what more is there left to do before we hand over to Simon and learn lots about clustering? Well, we need to actually apply that logical switch to something, because otherwise it's just sat in VMM. It's a VMM construct. So
what do we mean by apply? We're basically connecting that host, or we're connecting the logical switches to the logical networks, right?
Well, in a way, yeah. So when I say apply, I mean, okay, we've built this construct called the logical switch. It's got loads of policy and loads of settings. Now we just need to throw it onto a host so that that host uses the logical switch. At the moment, all it is a set of database items in VMM. We need to apply it to a host in order to have actually some use of the logical switch. So I've come over to Hyper-V 01, I've gone virtual switches. Here's the one we created earlier, that's a standard switch. Let's change that for new logical switch, or let's add another one. There's our Contoso logical switch. You'll notice I've only got one to choose from. If I'd have chosen the team option before, I would select multiple adapters here. But in this case, I haven't, so I'm just going to choose physical adapter number 3. It's going to apply that port profile, which is going to make certain tweaks and settings, and that's it. OK. And click Properties for the other one, for the other Hyper-V 02, Virtual Switches, New Virtual Switch, Logical Switch again. It's already got the name, it's already got the configuration. We just need to choose which physical adapter we bind it to. Boom. As I said, if we'd have chosen the team option, you would select multiple NICs in here between 2 and 32. Select the uplink profile. Obviously, across a team, the uplink port profile has to be identical and it will stop you from changing it. But when you click OK, VMM will do all of the teaming, set the right load balancing mechanism, set the right traffic distribution, do all of that for you. So it's really powerful. It would save those steps we did earlier when we created the team. I'm going to go OK, OK, and that, my friend, is pretty much us deployed. We've deployed a logical switch. It was pretty quick, but hopefully the building blocks have made sense. And as we said right at the start, we'll tell you later on how we can get you access to these labs so you can run through that in your own time with the lab manual as well.
You know, you bring up a really good point here, the logical blocks. That's kind of a consistent theme that we're going to see throughout VMM over the course of the day. Networking, storage, compute, memory, and then even our templates. You're going to see us break things down into these small, highly replicatable, manageable units, put them together, and that's how you're building up the solution. Well, with that, I think it's cluster time. So we do have a new poll. If you're in full screen mode, if you can minimize, respond to the poll, because there's a lot of you guys out there that haven't voted. And I am shocked to see, based on our initial survey results, about 40% of our customers here are not using clusters whatsoever.
What?
Shocking, I know. It's blowing my mind here. So hopefully I'm going to change your mind of why you want to use clustering and how clustering's a lot easier than it was in the past. Now, to start with, I mean, one of the comments, I actually asked, why are people not clustering today? They said, nightmares of clustering in the past. Yes, the ghost of cluster past still haunts a lot of people, but what we're trying to do is we've really reinvented things since 2008. Now, if you did clustering back in 2003, you did have that 50-page white paper. It was hard, right? I struggled when I first joined the cluster team as an engineer building my first cluster. I spent the first day on the job trying to build it, following the step-by-step guides, and I failed. I could not get it up and running. So for me, I totally appreciate that kind of initial feeling, that initial experience was rough. 2008 onwards, completely rewritten. Now when we build a cluster, everything is built on top of a best practice analyzer that we call our cluster validation wizard. It's going to test that the configuration is built correctly. It's going to tell you what's wrong if it is not built correctly, so you can get up and running with clustering little to no time. So let's take a quick look at what is failover clustering and how it fits in with virtualization. Now, we use failover clustering as our primary high availability solution. You do have an option of also using network load balancing, but network load balancing is really designed for redundancy. You have identical servers, let's say websites, that are running on VMs. You could distribute the traffic evenly across those websites. But the challenge with NLB is that it doesn't have a persistent and consistent data store. Let's say you have a SQL database. Well, we want to make sure that that information is always standardized. We always get the exact same view. And so this is why we use failover clustering for a majority of the features and roles in Windows Server. Anytime we want to have kind of a single interface or a single data store for our information. So what we do in clustering now, 2012 R2, is support 64 nodes, 8,000 VMs. We can actually cluster at the physical level, which is kind of traditional clustering. But we can also cluster at the virtual level as well. And we call this guest clustering. Now, if you think about what the cluster is, it's essentially a couple of servers that talk to each other and can fail over a workload from one node to another node, node A to node B. Now, whether that's happening on the physical level or on the virtual level, it shouldn't matter. When we have virtual clusters, we're essentially failing over the application running within our VM, like our SQL server, from one VM over to the other VM. So it's that high availability, but within our VM level. The third kind of area where we use clustering is for our scale-out file servers that we discussed earlier. That's where we have that client access point running on node 1, node 2, node 3, node 4, and that access point is highly available. If it crashes, we restart it. We can fail over client connections to ensure that our VMs always stay running, always stay highly available. Now, clustering supports a variety of different storage arrays, but key consideration here is that we always need shared storage. Now, shared storage could be a traditional SAN like iSCSI, Fiber Channel, Serial Attached SCSI, or even Fiber Channel over Ethernet. Or our shared storage can be the new Hyper-V over SMB. Because again, a file share is essentially a cheap form of shared storage. So all of these different types of mechanisms are supported. As far as networking goes, full support for IPv6, IPv4, and 4 to 6 tunneling technologies. Failover clustering is directly built into the Windows Server TCP/IP stack, so great integration across all of the different networking components. Final piece here is our cluster shared volumes. Cluster shared volumes is actually a distributed access file system. So if you think of traditional cluster storage, you have a disk that runs an application. Only one VM can access that disk at the time in the past. But we said, you know what, this doesn't make sense. We want to simplify our management. We want multiple hosts and multiple VMs to simultaneously access a disk. Similar to what VMware does with their VMFS. And so with cluster shared volumes, we can allow our VMs to run anywhere in the infrastructure on a single disk and all point back to that single shared file location. So that's the quick overview, but let's spend a minute going through the basics of how a cluster works. So key considerations we have. We need to have this shared storage. Again, traditional SAN or SMB if you're using a Hyper-V virtual machine. And for virtual machines, the shared storage is where we actually store our virtual hard disk on. So the VM is running on the physical server, but the actual VHD is running on our back-end SAN. Now, when we're running this application, health is important. And so all of the nodes are constantly monitoring each other to make sure that they are online and functioning. We do a health check basically through a simple ping, and then we do a more thorough health check occasionally. But basically, every node is just making sure every other node is healthy. Now, what happens is if one of our nodes crashes, we have an unplanned failure, maybe a blue screen, some other type of network outage where it becomes partitioned, those other nodes in the clusters are going to realize, hey, node 1 is out of commission. We can't talk to it. It's not responding to its health checks. At this point, this is where we trigger high availability. We trigger what we call a failover. Every node in the cluster knows what node 1 was doing. It knows which VMs were hosted on node 1, the state of those VMs, and so when node 1 crashes, node 2 through node 64, they're all going to talk to each other, and they're going to say, well, I'm going to take VM1, you take VM2, you take VM3. They bring everything back online. And remember, the data for that virtual machine, that virtual hard disk, is already accessible because it's on the shared storage. So essentially, when we're doing this failover, we're just reloading the virtual machine from its information on the shared storage onto another host. This is essentially how we're doing a failover and how we're introducing high availability. In this example now, we notice a crash, we notice health detection kicking in, and we see our virtual machines have failed over. Now, the next concept we're going to introduce is what we call our quorum configuration. Quorum is essentially a membership model to ensure that the correct hosts are running in a cluster. Now, the reason why we have to build this model is to avoid a scenario that is known as a split brain. A split brain essentially happens when you have one partition of hosts separate from the rest of the cluster. The challenge that we have is if these two groups of cluster nodes are unable to speak to each other, they don't see what each set is doing. They don't know who's running the VM, the state of the VM. And so we need to be cautious that we're not running two simultaneous instances of the same VM on these separate partitions. If that happens, we could have simultaneous data writes that could lead to bad things such as corruption. So the way we handle our membership model is we need a majority of nodes in the cluster to be online and running for that partition to be active. So let's say, for example, I have a 5-node cluster. So what we're going to do is we're going to assign each of those 5 nodes a single vote. What happens then is wherever we have a partition, if we have a partition with 1 node and 4, we have a majority of votes. This side of the cluster stays healthy, this side of the cluster shuts down. If we have our 5 votes and we have a partition here, we have 3 healthy members, they stay online. The 2 that are partitioned, they're going to fall out of membership. Once the partition disappears, they will rejoin the cluster and stay healthy. So let's go back to our graphic here and kind of take a look with a graphical example, what exactly is happening here. Now, in this example, we've provided each one of our nodes with 1 vote. So 4 nodes has a total of 4 votes. But one important consideration is to always make sure we have an odd number of votes. 3, 5, 7. This way, whenever there's a partition, we're always going to have a majority on one side. We can never have an exactly even partition. So in the case that you have an even number of nodes, like in this example, we're actually going to assign a disk an extra vote as well. So we have that 5 votes, 4 votes from our nodes, 1 vote from our disk. Now this means that whenever there's a partition, whichever node is currently accessing the disk basically now gets 2 votes. He gets his vote, plus he gets the disk's vote. So let's take a look at what happens when one of these nodes crashes. We lose the node, the virtual machine fails over, and we need to rethink about our membership. What's actually happened from before to after is we've lost the vote on node 1, and that would actually take down the total number of votes in the cluster to 4. But remember, we want to stay away from these even number of votes. So in Windows Server 2012, we've added a feature known as dynamic quorum. What dynamic quorum will do is it will actually toggle the vote that we have remaining on our disk. So if we have 4 nodes in the cluster, the disk gets vote number 5. If we have 3 nodes in the cluster, we get rid of that extra vote, so there's back to 3 total votes. So as we add nodes, as we remove nodes from the cluster, we're going to automatically toggle the voting system to always ensure that you have an odd number of voters, which will always ensure that your cluster, when there's a partition, will be able to pick side A or side B. Additionally, in this release, we've improved or reduced some of the Active Directory dependencies. You can now actually run a cluster in a read-only domain controller environment. In the past, we actually needed a writable domain controller to go and start up a virtual machine on the cluster, authenticating that the user could start it. Now, this caused some problems when all of our domain controllers were virtualized. When the cluster crashed, all of your domain controllers crashed, then you wouldn't be able to actually restart a VM. So we've reduced a lot of these active dependency restraints in this release, try to simplify our logic here. We've also added a feature that allows you to even drain roles to evacuate a host. So let's say I have 200 VMs running on a single host. We could say evacuate that host. It will live migrate all of the VMs off the host, drain it so that you could simplify your maintenance operation. Next thing we want to think about when we build our cluster is the networking on the cluster itself. Now, cluster, they have some special networking considerations, and we want to think about them uniquely for Hyper-V as well, because you see different type of network shape and patterns when you're using Hyper-V, as opposed to maybe more traditional network traffic like file shares, things like that. When we're thinking about designing our cluster networks, key thing to think about is separate them by usage. So you're going to have one network that's going to be for our live migration, where we're pushing a lot of traffic through the network as fast as possible. We're going to have a separate network for our internal cluster communication, including our heartbeat mechanisms. Now remember, the heartbeats, these are the health checks that we're regularly sending out. What happens if we try to send a heartbeat through a live migration network that's fully saturated with traffic? Well, that heartbeat's not going to go through, and that could trigger a false failover. So this is why we're really trying to separate this kind of burst traffic for live migration from our infrastructure traffic to manage the cluster network. Now, you're also going to have end users or end applications that are actually accessing your virtual machines or the applications running on the cluster. We want to isolate that public network as well. The reason for this is for security. Let's say we have this network that's actually attached to the internet, allowing our customers to connect to some local service. Well, we don't want to have a denial of service attack hitting our servers, flooding that network, that's preventing heartbeat traffic from coming through or live migrations from being successful. So we want to, again, separate that public network to access the VMs from our management networks, from our cluster communication networks. Then optionally, we have our storage network. If you're using an Ethernet-based storage protocol like iSCSI or Fiber Channel over Ethernet or Hyper-V SMB, you're going to have a dedicated network for that storage traffic as well. Same reasons here. We want to isolate it. We want to separate it. We want to make sure that you can write to your disk when you need to, and that disk access isn't being blocked by a live migration or a VM deployment. Now, when we actually go and configure a cluster, setting it up relatively straightforward, especially through VMM. What we're essentially doing with Virtual Machine Manager under the covers is we are calling the APIs through WMI for cluster. So we're saying, hey, I want to go deploy a cluster. We basically tell Failover Cluster Manager, go deploy this cluster. We have the option to specify the accounts, specify the names of the cluster, and then even do this end-to-end cluster validation test. We configure our storage, and we can configure our networking. Now let's actually jump over to our demo system and go ahead and build our first cluster here. So right now I'm here over on my Hyper-V host. We're actually using the same lab environment that Matt's been logged into. And I'm going to go and launch my virtual machine here. Now with Windows Server 2012 R2 Hyper-V, you're going to actually see one of my favorite features we'll be talking about later. The ability to automatically adjust the size of that VM connection window. So we can now go full screen directly from the host. And you can even do copy and paste now from our host directly to the VM. Don't need to go through these extra steps of attaching a new VHD or downloading things from the internet. Essentially what we've done is we've connected our hosts to our virtual machines through this conduit that we call the VM bus. And now we can go and access it just like it's an RDP session, copy, paste, resize, all of those great capabilities. All right, well, let's return back to the demo here. You can see the exact same environment that we've used. And under our Fabric workspace, we're now going to go and actually configure a few things. So quickly reviewing what we've done on our storage, if I take a look at my file servers, we can see that we've gone and configured this file server. We have file servers. It has 2 shares on this file server. But what I'm now going to do is actually attach these 2 shares to each of my individual hosts. This way, those hosts can deploy to those particular file shares. So I'm going to go expand my all hosts. I see Hyper-V host 1. Select the properties of this host. Take a look at my storage. Down here, under file shares, I can see currently don't have any file shares. Add a file share. And what this is now going to do is it's going to go and speak to my file server, my file share provider on DC01, and it's going to say what available file shares are out there. We got share 1. And let's go and add file share number 2. So again, we're just attaching this host to this particular set of file shares.
So VMM will handle all the ACLing and...
It will. It sets up the iSCSI initiator on them. Sorry, we're not using iSCSI here. Yes, it sets up the ACLing on that. Yep. If we were to go to configure it with iSCSI as an example, set up the iSCSI initiators. Absolutely. Yep. So VMM is basically being used as our logical management interface, right? This isn't the file server itself, but it's allowing us to go and connect to that file server. Add my file shares on my second host, share 1. And share 2. Click OK. And now both of my hosts can go and deploy to the file share. But we want to manage more than just at the individual host level. We're now going to go and actually create a new cluster from this. So under my Home tab, I can say I want to create a new Hyper-V cluster. So we're essentially skipping having to go through Failover Cluster Manager to go and build this out. We'll call this Contoso cluster. We could go and specify one of the run as accounts that we have. We'll use our VMM administrator. Click Next. Now it's going to give us access to any host which Hyper-V can manage that is currently, which VMM can manage that's currently not a member of a cluster. In this case, we can go and add these 2 nodes. Now, for the sake of the demo, I'm going to go and skip our cluster validation test. This will speed things up, but cluster validation is required to have a supported cluster. Highly, highly, highly recommend you do this. It's going to test your network, your storage, the software that's running on it, and even the virtual machine configuration to ensure that when you deploy a VM on it, it's already going to be healthy. So production environment, definitely want to go and run this. Now, you also have the ability to use cluster validation as a troubleshooting tool. Your cluster starts to perform oddly, something's not working. Run validation against it while it is in production, and it can help you determine what the problem is. And nowadays, customer support at Microsoft, if you call them up with a cluster issue, first thing they're going to ask for is the validation report. So trust us when we say this has been a great way to reduce costs, simplify the setup. And you know that story I told you at the beginning, how it took me a full day to try to build a 2003 cluster? Couldn't do it. With validation in 2008, I built my first cluster in 90 minutes. Not using any guides, just working through the validation wizard, showing me step by step what I needed to fix to go get my healthy cluster. So if you tried clustering in the past, give it one more shot. Try it again. Simplified now. Well, back to the wizard. We've now specified the host we're going to add. Click Next. It's going to ask us for an IP address to actually connect to the cluster itself. And we call this our cluster management point. Essentially, the cluster has an object in Active Directory that we want to connect to. So when we manage the cluster as a logical unit, as a collection of individual servers, we can manage this through a single point. And in this case, we are going to select a particular a particular network, and we're going to go and use the IP address pool. So remember this pool which Matt deployed earlier, the range of IP addresses? We're just going to go and pick a free one out of this.
You're going to pick one, or VMM's going to do it?
VMM is.
Yep.
So VMM will basically figure out what is free and go and assign that. Good clarification here. Now we'll go and add our disk to the cluster later. And now we go and actually specify which logical networks we want to go and actually give this cluster access to. Now, we've pre-deployed, pre-created a lot of these different logical networks here. What we really want to focus on is making sure that we can have access to our heartbeat network. No, we'll skip the heartbeat. We'll go to our corp network.
I think you just go next. We don't need to create any external virtual switches.
Already done that. Thanks, man. All right, so as we go finish up the settings here, confirm the information. Now, one feature of Virtual Machine Manager a lot of people like is this ability to go and view script. Everything in Virtual Machine Manager runs on top of PowerShell, meaning that under the covers, VMM is calling a PowerShell commandlet. As you go through a wizard, we actually document the exact commandlets that are going to be used to go and deploy this. You can go and save this, and you can reuse this script again and again, giving you the ability to do batch operations. So if you wanted to add 50 clusters, or maybe in the future you want to deploy 100 VMs, save the script, adjust the variables, make it highly reusable. We'll click Finish now, and we'll return to our lab. And what's basically going to happen in the background now is we're going to start deploying this cluster. As I click on the properties of this, I can see all of the individual steps that are happening, installing the features, validating the different components that they're healthy. But again, we're not going to go run this full validation test in this demo.
So this has essentially saved you doing all of this in Server Manager. Is that right?
That's correct. Yep, we skip Server Manager and Failover Cluster Manager. Skip a lot of that overhead. And you know, that's one of the goals of Virtual Machine Manager. Single interface, right? Trying to reduce people having to jump around to different locations or different hosts or configure all these remote connections. Try to use VMM as this single logical management piece.
But for environments that are small and just have a couple of nodes, 1 or 2 nodes, maybe 3, you can still do that in Failover Cluster Manager, and you can go through the validation. The wizard will look slightly different, obviously, but it's not far off as simple as what you've just seen with Simon. It's just a slightly different set of steps, but very, very easy indeed.
Right. Well, next property I want to talk about here is looking at how we go and manage some of the VMs on the cluster. We call this affinity and anti-affinity. And what we're really trying to do here is bind a particular VM to a particular host or distribute a collection of VMs. So let's first talk about affinity. Maybe over time you started to build up your infrastructure. You have some old servers, you're adding newer and more powerful servers to the cluster. And maybe you have a VM that can't even run on some of those old hosts. Maybe a high-end SQL application that needs 128 gigs of RAM. Well, you can configure Affinity to attempt to bind a particular VM to a particular group of cluster nodes. So you can prioritize it and say, hey, if this host is running, this VM should be placed on there. The thing that we also want to care about is anti-affinity. And anti-affinity means we're purposely going to try to split our VMs across different hosts. And we want to do this if we have similar roles that are virtualized. Let's say, for example, I have two virtualized domain controllers. If they are both running on a single host and that host crashes, I've kind of lost a key piece of my infrastructure. This has become a single point of failure because all of my Active Directory infrastructure is now offline. So what anti-affinity will do is anything that has the same name, the same set of properties, it will purposely try to distribute itself as evenly as possible across different cluster nodes. Another good example when this is used is if you create a guest cluster, which is a cluster made up of virtual machines. If I have a 4-node guest cluster that's running SQL, and I put that on a single physical server, I lose that physical server, I have that single point of failure again. So anti-affinity allows us to distribute our guest cluster nodes across different physical hosts, giving us even higher availability. Final property is what we call failover priority. Failover priority essentially allows us to assign an importance to our different VMs, high, medium, low. And then we have this fourth one that we say no auto start. Talk about that in a second. The way we use the priority is when we go and start our virtual machines from a cold boot, we're going to start all of our high priority VMs first, then our medium, then our low. Now this gives us the benefit of staggering the deployment, so we're not overloading the host when it's doing that initial boot up, making sure the high ones come online first. This also gives us the ability to go and stagger the different types of roles and when they should be deployed. I want to make sure that my Active Directory infrastructure is up first. That's going to be my high priority VMs. There may be key business resources, medium priority. Low priority might be the non-business critical virtual machines I have. Wait for the rest of the infrastructure to be healthy before booting them up. Then the fourth type we want to think about is called no auto start. Basically, this property says, virtual machine, if you crash, you're going to stay offline until I manually restart you. I want to ensure that my low, my medium, and my high priority VMs all come online first. When my entire infrastructure is healthy, then we'll go and add those dev and test and those non-important VMs that are just spinning there. So a lot of flexibility in how you stagger that infrastructure. We also see people use this staggered approach and prioritization when they're deploying multi-tiered applications. They need that back-end database to come online first, high priority, the business layer coming on second, medium, and then kind of the web portal, front-end web servers, those can be a low priority, making sure they come online last, so that those dependencies throughout our stack are already online, already healthy. Now we've added virtual machine monitoring as well in Windows Server 2012. What virtual machine monitoring does is it allows us to actually peek inside the virtual machine at any of the services that are running within that VM. So as we kind of think about high availability throughout the stack, we start with our physical servers. They're monitoring each other. They have failover. We then monitor the virtual machines themselves, whether the VM is healthy, if it's crashed, if it's restarted. Going the next level, we monitor the health of the guest operating system within that VM, whether it's got a user level hang, whether it's blue screened, any type of issue with the VM's guest OS. This is now the next level. This is not just looking within the VM, but looking at all of the services within the VM. So if you have a custom application or any other type of standalone service that's running within your Windows VM, we could go and monitor the individual service that's in Service Control Manager, restart that service, restart the VM if that service keeps crashing, or even move that VM over to a different host. So we're really trying to build high availability throughout the stack here. Well, let's switch back to our demo, and we're going to go take a look at some of these additional configuration steps. Now, by now, my cluster has been built. It's installed successfully. I can take a look at the details. Everything appears to be running healthy. So we'll close our jobs window. And now if we look at our fabric, we can see Contoso Cluster 1 has now been created. So we're going to go and edit some cluster-wide properties next. To do that, we select our cluster, click Properties, and again, these are going to be properties that are applied to the entire cluster. Under the General tab, you're going to see the minimum number of nodes that are required to be online for the cluster to stay healthy. This is what we call a reserve. So let's say you have a 64-node cluster, and you say as long as 10 of my hosts are healthy, the cluster will stay online. We can go and manage it using this setting here. When we look at the status, we can see that my resources are healthy, but not following a best practice here. It's reminding me cluster validation hasn't been run. So I would want to go and make sure I do that.
Now to add, if it had been run, it would provide the link right underneath there. So you could click on it and you could view the report for, if you ever got into a problem and Microsoft support said, have you got your validation report, you click yes, here it is. So that's where you would find it.
Then this is a great point. The persistability of what we do with all of our reports. Anytime you run a report in a cluster, from creating the cluster, adding a virtual machine, adding storage, and of course cluster validation, we always save that report on every single cluster node. This way, if you have a particular node that's crashed, you don't have access to it, you can still inventory things and have an understanding of what has been done that led up to the point of that failure. And we hear that certain customers that have compliance and documentation requirements for their infrastructure love to use this tool because it details the inventory of how this cluster is configured. So this is a document that's saved as a single page web page. Easy to share, easy to distribute, post it onto a SharePoint site even if you want. So a lot of flexibility with kind of our ongoing maintenance and support. Now what we're going to do next is we are going to go and actually add some storage to this cluster. So I can go take a look at my file share storage, and I can go click Add. And this is going to basically make sure that not only have my individual hosts have access, but this cluster as a whole now has access to my file shares. So I've added file share 1, file share 2. What this means is anytime I now deploy a VM on my cluster, I'm going to be able to go and pick any of these paths. Now a little earlier you saw me set this up on the individual host, and now I'm setting it up on the cluster level. So this gives me best of both worlds. If I want to deploy a standalone VM on that host, I can do it on the file share. If I want to deploy a clustered VM on that host, I also now have that capability. Next thing we're going to take a look at is adding some of our available storage. And so this is essentially connecting to our iSCSI target and giving us the ability to go and create a new LUN. So in this case, I'm going to say I want to go create a new logical unit. Oh, sorry, let me step back here. First thing we're going to do next, actually, is we are going to go, sorry, let me save these changes. Let me just save my changes for my file server. Next thing we're actually going to do here is we're going to go and assign some storage to this host. So the reason why I can't actually access this storage and deploy it from the cluster yet is I haven't gone and connected that to my iSCSI. So next thing I'm going to do here is I'm going to go to my classifications of my storage. I'm going to go and say allocate capacity. So I've gone and created this iSCSI target. We've got a CSV disk.
That's the one I created earlier.
That's the one Matt created earlier. And we're going to say assign this logical unit. We select the one we've created, we add it, click OK. So now this is added to this different host group.
We'll add the storage pools as well.
We're also going to add our storage pool here. So Matt, what's kind of the difference of why we're adding the storage pool as well as adding the LUNs here? What's the benefit of making sure we do both?
Well, because the storage pool could be a collection of LUNs. So you're effectively allocating the whole pool and making it available to a set of servers, and then you're allocating the LUNs within that. Because you may want to allocate a pool across a large number of servers, but you may only want to allocate certain LUNs across a fewer number of servers. So this gives you the granularity by separating those out. So it gives you that flexibility to administer and manage all of that. That's the key thing, key takeaway.
All right, well, we'll close this down. So now we've gone and basically allocated this, said this storage is available for usage. We're now going to go back to our hosts, and we're going to go and connect all of our hosts to our storage. So go back to my properties of this Hyper-V host, take a look at my storage, add the iSCSI, select the array,
So this is essentially the same as you go into every individual host manually in Windows Server and essentially saying, okay, iSCSI initiator settings open, connect to this iSCSI SAN, establish a session, and then move on to the next one. So this allows you to do it from VMM instead. And you can establish multiple sessions just in the same way that you would do from if you were doing it within the iSCSI initiator directly on the host itself. So it just centralizes all of that and makes it a lot easier.
Right. So yeah, we're not going to these different locations. We now have access to this array.
Yeah.
And so essentially, yep, configure iSCSI, connect it up. We
Yep.
can now deploy. We can carve up LUNs, manage as we need.
So what we've just done there, just to elaborate, we created the LUN in a couple of modules ago. We had that LUN just sat there, not being connected to anything. That particular LUN was part of a pool. We've now exposed that LUN and that pool to a set of hosts, but not attached them. We've just said, yeah, you can use them if you want, but we've not attached them. And now what you've just done is said, iSCSI initiator on each of the hosts connected to the storage pools, so the iSCSI SAN. So now everything comes together. We're obviously using SMB storage, so you don't necessarily need to use iSCSI as well. It's just we're showing you both.
Best of both worlds.
Yeah, if you've got iSCSI and not SMB, that second half of that demo is going to be more relevant to you.
And what we saw from our statistics, we saw a lot of people with iSCSI,
Yep.
a lot of people with Fiber Channel, and we're seeing an increasing use of SMB as well. So getting up there, that probably means a lot of people are, gradually adopting the 2012 release as
possibly,
well.
yeah.
So now we're going to continue here. So we've gone and connected our storage to the individual hosts. Let's go and make this clusterable storage now. So as I look at my shared volumes here, I can go and click Add. Now remember, Node 1 can access this disk. Node 2 can access this disk. So this can essentially be a clusterable disk. We're going to quick format this. We'll give this a name.
You want to force it as well, just so.
Let's force it as well.
Why not?
Click OK.
So that's the LUN that we created earlier as well.
That is. And so we now have access, and we've created a cluster shared volume. Again, this is that distributed access file system that's optimized for Hyper-V. So now we basically configured the cluster. We've connected to our networks. We've connected to our storage. Next thing we want to think about is just some additional types of optimizations that we're going to want to do here.
It's important to call out as well, that last step that Simon went through where he created that shared volume. There was a lot of stuff going on under the covers that was masked from the user. So for instance, all we did, that CSV1 disk that I created earlier in the lab, at that point it was literally just a raw disk. It wasn't NTFS file formatted, it didn't have a drive letter, it was literally just...
It was unusable at that point.
It was just a raw disk that had been presented from the iSCSI target to the Hyper-V host and the cluster. And going through that shared volume wizard, although Simon only had to tick a couple of boxes and enter a name, and clicking OK, VMM is then triggering the attachment of that particular disk to both hosts. It's the formatting with NTFS, the presenting as a cluster shared volume through to the host now. So if you went to each of those Hyper-V hosts individually onto the C drive /cluster storage, you would see volume 1 to reflect that LUN. So on each of the nodes in the cluster.
Great, thanks, Matt. What we're now going to look at is some additional optimizations. First one we want to talk about is what we call dynamic optimization. And this would be equivalent to VMware's distributed resource scheduler. What dynamic optimization does is it's basically load balancing the memory across your different hosts. So what we're currently doing is Virtual Machine Manager has a collection of servers, or a cluster in our case, and it's monitoring resource usage. We get to set what we call an optimization threshold, which is essentially a percentage of our resource utilization that we do not want to pass. As soon as we pass this, we're going to start to trigger live migrations and try to rebalance the cluster so that all of the hosts stay under that maximum. Essentially, our objective here is to not overload an individual host so it doesn't run out of resources or capacity, doesn't perform badly. We want to kind of maintain a level playing field across these different hosts. This is going to ensure that you have better performance and more predictable maintenance. Now, with the dynamic optimization, we support heterogeneous clusters as well. So this means we're not just load balancing on our Hyper-V clusters, we also support VMware. Now, a common question I get is, okay, I have VMware, I have Hyper-V, I have VMM. Should I use dynamic optimization or should I use DRS? Our answer is use one or the other. If you don't want to use them at the same time. they don't really talk to each other, so they don't really have awareness of the placement policies for each. So they could kind of be fighting each other over placement. So again, either DRS or dynamic optimization. The choice is yours. Now we'll go through some of these additional settings as we actually jump to our demo. Final thing we're going to cover here is an additional step beyond dynamic optimization known as power optimization. In this case, we set a minimum optimization threshold. And if our hosts fall below this minimum, we're actually going to go turn them off. So the idea behind this is for green IT, power saving. If you don't need a host to have it running, let's turn it off. Once you start to need that, maybe you're a 9-to-5 business, turn it off in the evening, turn it back on in the morning. We will start to automatically reprovision and reload balance using our distributed resource scheduling. So you kind of get this best of both worlds here. Load balance when you're at overcapacity, turn off virtual machines when you're running at undercapacity. So let's switch back to the demo and we'll show you how we're doing this in production. So I'm back to my cluster here, and I'm going to select my properties.
You want to change the cluster reserve?
I do. We're going to go select the properties here for our actual group here, and we're going to go click our host reserve. So host reserves, this is essentially policies that are applied across all of our different hosts. So we can go and adjust the amount of minimum memory, the amount of minimum CPU. Now, in our lab, all of our virtual machines in this environment, they're only running about 2 gigs of RAM. So if I went and said that the minimum required RAM on these particular hosts we're going to deploy to is 2 gigs, we're going to get errors. It's going to say not enough free memory. So I'm just going to bump this down really low. Let's just say to 128 megabytes of minimum RAM. Again, just for the lab, not going to be a best practice because you're probably going to need more than 128 gigs of RAM for a real host in production. Next thing we're going to take a look at here is our dynamic optimization. First setting we can look at is how frequently do we want to try to do our load balancing. And by default, we use 10 minutes. Now, this kind of depends on some of your own environmental considerations. And we do this based on aggressiveness to how frequently we want to load balance it. If we want to load balance more often, you're going to have more network traffic because it's going to try to distribute the hosts evenly. You load balance less often, say maybe once a day, you're going to have less network traffic because it's analyzing the state of the clusters less frequently. Now we also have this aggressiveness setting. This is essentially saying how even do you want it to be balanced. If you say you want it to be very aggressive, it's going to try its best to make things completely even. 50%, 50%, 50%, whatever that threshold is across every single node in the cluster. Most people don't like making it highly aggressive. A lot of people will turn it down to low. This allows a little more flexibility. So maybe you have one node that's running at 40% capacity, another at 60% capacity. That's okay. As soon as one of those bursts over that threshold, hits that 80, 90%, we're still going to go and trigger our load balancing. Down here we have our power optimization setting. Now power optimization is dependent on dynamic optimization. If you don't have dynamic optimization running, you're not going to be able to go and use power optimization. As we look at the settings, we get to go specify some of our minimum thresholds. When things drop below a certain amount, that's when we can make changes. Over here on our schedule, we have the ability to kind of specify what hours we can do power optimization during, and then also what hours it's not acceptable to do power optimization.
It's like a really exciting game of Minesweeper.
Really exciting.
Yeah, I mean, you'll never hit a mine, but just keep going.
Smiley face built in.
Randomly operating throughout the day.
So that's kind of a quick summary of these different host configurations that we have here. Click OK, and let's go back to our demos. Sorry, back to the presentation here. Power optimization details, configurable. Look at all the different resources for when we turn things off.
So it's important to know that that requires the baseboard management controller that I referenced earlier when you're deploying Hyper-V hosts. If you were using VMM for that, you're going to have an out-of-band NIC, if you call it that, on your chassis. And that's what VMM is going to use to wake up and power down the particular Hyper-V host. It's not going to rely on the magic packet because we know it's not necessarily 100% reliable all of the time, so for things like wake on LAN. So it's going to use that baseboard management controller to trigger the waking and the shutting down, if you will, of the Hyper-V hosts. And it's important that even though we specified those times in that Minesweeper-esque experience, should demand suddenly spike during that time when power optimization is operating, i.e. you've got a reduced number of hosts, should demand spike, VMM will notice that and it will wake hosts up from their slumber to actually handle that extra load. So it's not as if once they're off, they're not coming back on until 9 o'clock the following morning. It will react based on changing environments.
Great. Now we're going to go and start to talk about one of the favorite features. In fact, this is one of my favorite features. I helped build it, so I have a lot of personal connection to cluster patching here. But this is designed to solve one of the most boring, most tedious challenges that people have, patching clusters. So let's be honest here, Microsoft has a lot of patches, okay? Let's get that out of the way. But what we're trying to think about is simplifying that patch management experience. What we're able to do with our centralized patching is we're able to use either cluster-aware updating, which is built into Windows Server, or Virtual Machine Manager's own cluster patching technology to go and basically figure out what hosts are in the cluster and apply the appropriate patches while ensuring there is no downtime to any of our running virtual machines. We do this through connecting to Windows Server Update Services, or WSUS. This allows us to download the current list of patches that are available from WSUS and to create what we call a baseline, which is basically a collection of patches which should be applied to a particular host. We can then scan our groups and we can do what we call a remediation, which is actually applying all of those necessary hosts to all of those particular servers. So let's go ahead and actually take a look at this in action one more time. I'm going to switch back to my demo system here. I'm going to go back into Virtual Machine Manager. And as I take a look at my fabric, we can see that I have an update server that is already configured. So we could see here, VMM01 contains our update server. And so basically we've gone and installed WSUS on this. We've synced it to Windows Update. It has all of its necessary patches. Now in our library, this is where we're actually going to go and view all of our updates. So I can take a look at my update catalog and see these updates that are available through WSUS, critical updates and security updates. Now this will actually allow you to integrate with any type of update category that WSUS provides. So if you have things like third-party updates or driver updates, those would populate down here as well. Now, as far as what we can actually patch, we have the ability to patch the different roles that are included under our infrastructure. We can patch our hosts in our clusters. We can patch our library servers, Pixie servers, the WSUS server itself, and the VMM server. One exception here, though, is our vCenter servers. If we had any VMware hosts in here, we would not be able to patch them. VMM patching is outside of the scope of what we're able to manage with Windows patches because it's not actually running the Windows operating system. So let's go back to our baselines and kind of take a look at what we're going to go do, what we're going to go patch. So I'm going to select my update baselines here, and I'm going to select create a new baseline. We'll give this a name, Contoso Baseline. Click Next. Take a look at some of the updates that we want to add. And in this case, I'm just going to go pick these, let's say these two at the bottom here. It's my critical updates. Now, again, we can scope this, we can adjust, we can create as many baselines as we want. Next thing it asks me is, which of these servers should this baseline be applicable to? In this case, we're just going to select our cluster. These are the patches that we want to apply to this particular cluster. We get the nice view script option. Click Finish, and this has gone and created this logical concept of what we call a baseline. So now that we have our baseline, next thing we want to think about is actually compliance for this baseline. We want to think about being able to go and scan our infrastructure. So let's go back to our cluster, and let's go and click on Compliance. What compliance does is it's going to basically figure out what patches are running, what patches are not running. And in this case, since we've just added this baseline, we want to actually go and run our compliance scan. So I click Scan, and this is going to go speak to each of the different hosts. It's going to look at which of the patches are currently installed across each of the hosts, and it's going to tell us which patches are essentially missing. Now, what it's done is it's told us, hey, we're all good, this is compliant, everything is good to go. So this gives us a nice ability to really go and figure out, hey, this was easy to use, I have a centralized view across all of my different servers. So next thing that we have the ability to do is actually create some exemptions for a particular server. So if, for example, I decided that this particular host should not even have this one, we can go and create a particular exemption. So giving you some flexibility here in how you actually work with all of these different hosts. Create an exemption, click OK. That patch is no longer required. So now that we've gone and actually applied all of these, if we had any that were missing any patches, we could simply say remediate. And remediate will go and actually kick off the patching cycle. What it's going to do is ensure that it maintains high availability. We take one node at a time, and we place it into what we call maintenance. Maintenance means that it's locked. Nothing can come onto it. We don't want to be adding VMs, have them live migrate over. So it's locked from anything coming in, and it will then start to evacuate the nodes automatically. It drains them using live migration and using VM prioritization. So it gets those high priority VMs off first, then medium, then low. You may want to do this in case you have, a high priority virus, want to drain the host as quick as possible. Once all of those high priority VMs are over, cut it, speed things up, and just do a traditional failover with the other VMs. But essentially, once we've gone and drained this host, we go patch it, restart if it's necessary, and then we're going to check for three things. We check that the server has successfully restarted, that the patch installation code returns as successful, and that the node can rejoin the cluster. When those three requirements are met, we say the patch is successful, we take it out of maintenance mode. VMs then may load balance automatically, they may reload balance after a period of time with dynamic optimization. Doesn't really matter, but things can move back to it. We then pick the next node in the cluster, maintenance, evacuate, patch, out of maintenance, rebalance, and continue cycling across all the different nodes in the cluster. So kind of just with a few clicks, you can go and set up the cluster patching, go away for the evening, come back the next day, and your cluster should be fully patched and fully compliant. So let's take a look at VMware and how they kind of stack up with some of these cluster management capabilities. Well, the free inbox version, unfortunately, doesn't really have any of these capabilities here. There is no clustering available. But yet, with Hyper-V and even the free version of Windows Microsoft Hyper-V Server, all the clustering capabilities are built in, including cluster shared volumes, 64-node clusters, 8,000 VMs, and virtual machine monitoring. So inbox and free with Hyper-V, additional costs if you're looking at using this with vSphere. Now, final point we're going to spend a minute on is kind of looking at guest clustering here. We talked about this earlier, where this is our cluster on top of a cluster made up entirely of virtual machines. Now, for the VMs to go and connect to storage, they need to make sure that they can support that storage protocol going through the virtualized stack. Because remember, these VMs, they also need shared storage. They need that single consistent view of that SQL database for SQL that's running inside the VM, allowing SQL to fail over between those different VMs. So the guest cluster can attach to iSCSI, Fiber Channel over Ethernet, or SMB, so long as it's communicating through one of the network protocols or through our virtualized Fiber Channel HBA. But when we have a guest cluster, we still support live migration. We still support backups. We still support draining nodes, both on the physical and on the virtual layer. We also introduced this concept in 2012 R2 of a shared VHDX. Shared VHDX essentially is a new type of shared storage that we can make available to a guest cluster. Here was kind of the scenario of why we introduced this. When we had a lot of hosters that were allowing their end users to go and deploy clusters in their environment, they would actually have to carve out LUNs and present the storage topology to their end users. Hey, SQL DBA, you're saying you need to make your virtual SQL server highly available? I need to start to give you access to my underlying storage system, give you a SAN, have you manage it at the SAN level through Fiber Channel, through iSCSI, whatever. So we wanted to really abstract that. What we can now do is create a VHDX file, which is basically a virtual hard disk as a container. We can hook up VM1 to it, hook up VM2 to it, and this can essentially function as shared storage. If I have a SQL application running on my VM, the SQL database is now stored in that shared VHDX. So it's security and obscurity through abstraction, giving you kind of another additional security boost here as well. Taking a look at what VMware does here, maximum cluster sizes for guest clusters limited to just 5 nodes in VMware. And they're actually running Windows Server failover clustering. So if you already got failover clustering deployed on your VMware infrastructure, it's going to be kind of similar deploying it on your physical Hyper-V infrastructure if you move over to the Microsoft stack. And there are no other limitations as we're looking at our virtual guest clusters here. A lot of limitations if you're doing guest clustering with VMware. So Matt, we'll switch it back over here. It's 12:15. I think it's going to be an appropriate time for us to wrap up this session. We're going to be taking a break for approximately 45 minutes. We'll be returning at the top of the hour, and we will see you shortly. When we return, we're going to take a look at virtual machine configuration and then start to go up the stack looking at different management capabilities using System Center 2012. Thanks.